Welcome back, everyone. In this lecture, we're going to be discussing generators. We've already learned how to create functions using the def keyword and the return statement. Generator functions allow us to write a function that can send back a value and then later resume to pick up where it left off. So as I mentioned, that type of function is a generator in Python. The basic idea is that generators allow us to generate a sequence of values over time, instead of having to create an entire sequence and hold it in memory. The main difference in syntax when you're programming is the use of a yield keyword statement. So when a generator function is compiled, they become an object that supports some sort of iteration protocol. That means when they're actually called in your code, they don't return a value and then exit. Instead, generator functions will automatically suspend and resume their execution state around the last point of value generation. The advantage here is that instead of having to compute an entire series of values up front and hold it in memory, the generator computes one value and waits until the next value is called for. So you can imagine if you wanted to get all the numbers between 1 and 1 million. You have two options here. You can either start generating values 1, 2, 3, 4, and then feed them that way, for example, in a for loop, or you would create a giant list of numbers, 1 through a million, and then slowly pick off those numbers from memory. So this is what the range function is actually doing the first way. It's generating numbers. So instead of producing that giant list from 1 to 1 million in memory, since that's kind of wasteful if you're using it in a for loop, instead what it does is it just keeps track of the last number you asked for, the step size, which by default is 1, to provide a steady flow of numbers. So it's generating the numbers over time instead of creating a giant list in memory. Now, if the user did need that list, what they have to do is transform the generator to a list with list range from 0 to 10 or 0 to a million or whatever their start and stop values are. So that's why when we're working with range, if we actually wanted to get a list of numbers, we had to cast it to a list because range itself is a generator and it's just remembering the last number it sent out and then the step size to generate the new number. That way it doesn't have to store this huge list in memory and it makes it a lot more efficient. So let's explore now how to create our own generators. We're going to open up a Jupyter Notebook. In order to get that better understanding of generators, we're going to create some. First, I'm going to create a normal function. And this function is going to be called create cubes. And what this function does is it's going to create a list of cubes from 0 up to n, whatever number the user asked for. So in this case, we'll say result is equal to a list, and then we will say for x in range n, take result and append x to the power of 3, its cube. And then at the end, we're going to return result. So if I wanted to create cubes up to 10, I run this and now I get back this list. So notice what's happening when we actually work with a normal function. We have to create an empty list, and then we go for every number from 0 up to that value. We append the cubed value to this result. So we're keeping this entire list in memory. Now, that may be useful if you actually want the list, but sometimes maybe you just want to say for x in create cubes, print x. Now notice what happens when we print them. We actually really only needed one value at a time to print them. We didn't need that whole list stored in memory. In fact, we just need the previous value and then whatever the formula is to get to the next value in order to generate all these cubes. So instead of actually creating this giant list in memory, it would be better if we just yielded the actual cubed numbers. So that's what we're going to do now. So let's go back to this create cubes function. I'll zoom in here. I don't need this list anymore because I'm not going to store any of this in memory. Instead, what I'll do is say for x in range n, instead of returning the result at the very end, I'm just going to call yield, and this is a keyword, whoops, Y-I-E-L-D. I'm going to yield that cubed x value. And then if I run create cubes now, I get back the same results. It says for x and create cubes, print x, and I'm getting back the exact same thing. Except now, create cubes is way more memory efficient. The first way, if I had passed in a really big number here, it would have had to create that entire list in memory of the cube numbers from 0 to 10,000. And then from there, if we wanted to iterate through it, we would have had that list in memory. But now I don't have this list in memory. Instead, I'm just yielding the values as they come. So then create cubes here is a generator. It's generating those values as you need them. Now keep in mind, let's turn this back to 10. If I were just to call create cubes by itself, I no longer see that list. I just see, hey, you have a generator object here at this location in memory, and you need to iterate through it if you actually want the list of numbers. If you do end up just wanting the actual list itself, you could cast it to a list and then get back the list. But create cubes itself has the option of just yielding it to be more memory efficient. So let's now create another example which calculates a Fibonacci sequence. And a Fibonacci sequence, all it is if you have a number A followed by a number B, then B is defined as the sum of the last two numbers. So let's actually show you what I mean by that. We're going to say DEF generate Fibon for generate Fibonacci. And it's going to generate a Fibonacci sequence up to n. So we can start with A equals 1 and B equals 1. Other Fibonacci sequences start with A equals 0 and B equals 1. It's really up to you. And we'll say for I in range n, I'm going to yield A. And then in order to actually recalculate A and B for the Fibonacci sequence, I can do the following. I can say, do a little tuple matching here. AB is going to equal to B, A plus B. And this allows me to avoid any issues with trying to reassign A and B while they're still being played around with. So let's walk through what's happening here. The generation of the Fibonacci sequence, it starts with A equal 1, B equal 1. For I in range n, we yield A, and then we're going to reset A to be equal to B, and then B is going to be equal to the sum of that previous A plus B. So in this case, in this first round, we have 1, 1, and then we have 1, 2. And then from there, we have 2, 3, then 3, 5, 5, 8, 13, 21. And we'll be able to see this when we run this. We'll say for number in generate Fibonacci up to 10, print the number. And we run that, we get to see this Fibonacci sequence occur. So what if this was a normal function, just to kind of show you the difference between yielding something and creating a normal function? In that case, we would have to store everything. So we would have to say output as some empty list, and instead of yielding everything, we would have to say output append A, and then after we did that entire for loop, I would end up returning the output. And if I run this, it looks the same as the results, but this is way less memory efficient because I'm holding everything in a list in memory instead of just yielding them as I need them. So when you want to iterate through some sort of generation sequence, it becomes a lot better to use this yield keyword instead of storing thing in a list, especially if you expect that number to be really large and if you're creating a huge list. So the key to fully understanding generators is the next function and the iter function. So let's explore those concepts now. I'm going to create a couple new empty cells here. We'll first start off with the next function. So to do that, I'm going to create a very simple generator. And all this generator does is it says for x in range 3. So I've already predefined the range. We won't have the user pass that in. I will yield x. So what does that actually mean? It means if I say for x in simple gen, print, actually let's say number so we don't get confused by the x in there. We say for number in simple gen, print number, I get back 0, 1, 2. So let's now assign g equal to a new instance of simple gen. So notice here I'm actually calling simple gen here. And let's take a look at g. It's this generator object, and I can ask for the next g, and let's print out the result here. And I get back 0. So then if I ask for the next one, after that, I get back 1. And this is what the generator object is doing internally when you call that yield keyword. It's remembering what the previous one was and then returning the next value, given whatever formula it's following. It's not holding everything in memory. So then we can print out the next G, and we get back 2, and then eventually you're going to see, because we only went up to 3, it'll say stop iteration, because after yielding all the values, next calls a stop iteration error. And what this error does is it informs us that all the values have been yielded. Now you may be wondering why we don't get this error while using a for loop. And that's because a for loop automatically catches this error and stops calling next. So this is another interesting thing to think about. When you're actually calling this for loop on this generator, what the for loop is doing is it's saying, hey, give me the next thing, hey, give me the next thing, hey, give me the next thing. So that's what this for is doing internally on this generator object. Finally, I want to show you the iter function. So ITER. And the iter function basically allows us to automatically iterate through a normal object that you may not expect. So I'm actually going to first say s is equal to hello. And I already know I can iterate through the string. So I can say for letter in s, print the letter, and I get back HELLO. Now, unfortunately, that doesn't mean the string itself is going to be able to iterate with the next function. In fact, if I say next on s, it'll say, hey, this string object isn't an iterator. So what this actually means is that the string object does support iteration because we went through a for loop on it, but we cannot directly iterate over it just like we did with a generator using the next function. In order to do that, to basically turn this string into a generator that we can iterate over, we're going to say s underscore iter, and then we call the iter function on it. And then now we can call next on the iter version of it to get back h, and then we call back next on the next one, we get back e, and so on. So now you know how to convert objects that are iterable into iterators themselves. And I know there's a lot of kind of strange semantics here, the iterators, iterable, and generators, but the main takeaway from this lecture really has to do with that yield keyword. So if you scroll all the way back up, if you really are going to take one thing from this lecture, it's really how to create your own generators with yield. Usually when you're working with code, you're not going to be actually using that next function that often, and you're not going to be using that iter function that often. Really, those are being called behind the scenes for you already. What you will be using is this yield keyword when you eventually find yourself creating your own generators. You can check out the notebook, which has 2 links at the bottom for really useful Stack Overflow answers, explaining some more aspects of generators. Coming up next, we're going to just quickly check your knowledge to make sure that what we discussed about the yield keyword stuck with you. So we'll see you at the next lecture where we go over some generator questions. We'll see you there. Now that you know about the yield keyword and how generators work in general, what we want to do is test your knowledge with some homework questions. Let's jump to the notebook, go over the questions, and in the next lecture, we'll go over the solutions. Okay, if you go to the Python generators folder, you should be able to find the iterators and generators homework notebook. There's a solutions notebook that goes along with this. And the first problem is to create a generator that generates the squares of numbers up to some number n. We did a really similar example of this in the actual lecture. And then problem 2 is to create a generator that yields n random numbers between a low and high number. So those are the inputs. You have a low number and a high number, and you want n random numbers. Remember, they're generated using the yield keyword. And then problem 3 is to use the iter function to convert the string below into an iterator. We pretty much actually did this exact same thing in the lecture before this. And then problem 4, this is just something to kind of think about. And it's mainly to explain a use case for a generator using a yield statement where you would not want to use a normal function with a return statement. And this was kind of the same thing I was saying over and over again in regards to memory management. And then here we have a quick extra credit problem where can you see if you can explain what's actually happening here with this gencomp variable. So we've never really covered this in the lecture because it's a pretty advanced topic, but you might be able to figure it out if you Google generator comprehension. And more or less, that's actually the answer itself, but maybe you can explore this a little more. Okay, we'll see you at the next lecture where we go over the solutions. Welcome back. In this lecture, we're going to go over the solutions for the iterators and generators homework. Because the solutions themselves didn't require that many lines of code, we'll just browse through the solutions notebook and explain the solutions there. Let's get started. Okay, here I am underneath the Python generators folder. There's the iterators and generators homework solution file. Let's go over problem 1, whereas you needed to create a generator that generates the squares of numbers up to some n. We actually did a very similar example of this in the lecture for generators. All you had to do was say for I in range n, and then you wanted to yield the squared of I. And then you could then create a generator and print out those squared numbers. Problem 2 was a very similar problem, except we wanted you to create a generator for random numbers between some low and high number. And in this case, what you're doing is instead of yielding the square of the number, what you do is you take advantage of this random rand integer function and then yield some random.randint and then pass in low and high. Because remember, this function itself is going to generate a number, and then what we're going to do is then yield it in order to create a generator out of this entire function. And here we have the generated random numbers. Problem 3 was to use the iter function to convert the string below into an iterator. We actually did this exact same thing in the lecture for this, but all you had to do is say s is equal to hello, and then pass it into the iter function, and that's it. You can then call next on s, and it's gone from being an iterable to an iterator. Problem 4 is to explain a use case for a generator using a yield statement where you would not want to use a normal function. And basically this is the thing I've been saying all along during the lecture, is if the output has the potential of taking up a large amount of memory and you only intend to iterate through it, you don't want the entire thing at once, then it makes sense to use a generator. And then the extra credit was, can you explain what a gent comp is below? So we actually didn't cover this in the lecture, but if you Google generator comprehension, this is exactly what this is. It's like list comprehension, but instead of actually creating the list in memory, it's going to generate it. So all you need to do here is switch out the square brackets for parentheses, and now you've turned your list comprehension into a generator. So then you can iterate through the generator and not hold all of this in memory. Okay, hope that was useful to you. If you have any questions, feel free to post the Q&A forums. We'll see you at the next lecture.